Hello, everyone. Welcome to another live lesson at HiPrep. My name is Chinedu Wamade. So today we're going to begin a lesson on quantitative chemistry, and I'm going to start from the relative formula mass, okay? So let's start. Okay, this lesson is going to cover the meaning of relative atomic mass and relative formula mass. Also, how to find the relative atomic mass and relative formula mass. Okay, now. Before we go into finding the relative formula mass, I need you to understand mass number and as well as the relative atomic mass. So the mass number is just the total number of protons and neutrons of an atom located in the nucleus of that atom. Okay, well, now when you look at the periodic table, at the top left corner, you see a number. That number tells you the mass number of that particular element. Okay, for example, let's look at carbon. So carbon has a mass number of 12. You can see it is located at the top right, top left corner, okay? Now that 12 tells you the total number of the protons and the neutrons of this carbon atom located in the nucleus as well. The next is the relative atomic mass. The relative atomic mass is always noted with the word AR. Now, this is the average mass of the isotopes of that element, okay? Now, there are instances whereby an element will have atoms with the same atomic number but different mass number. And those are what we call isotopes. For example, a chlorine atom has a mass number of 35, and also another chlorine atom has a mass number of 37. But chlorine as an element has a relative atomic mass of 35.5. Now, this is the average mass of these two isotopes. Now, there will be instances where we will ask to calculate the average mass of a compound where two or more different kinds of elements are involved. Now, that is where the relative formula mass comes in. Now, the relative formula mass, which is always noted as the word MR, is just the adding of all the element masses in that compound, okay? Now, how do you find this? You add together the relative atomic masses of all the atoms in that compound's molecular formula. Now, let's look at an example. Sodium chloride with the molecular formula of NaCl, okay? We have one atom of sodium in this compound multiplied by its atomic mass. Oh, so we have one atom of chlorine in this compound multiplied by its relative atomic mass. So we like I said, add together the relative atomic masses of all the atoms in this compound. So we have 23 plus 35.5, which will give us our MR to be 58.5. Okay, good. Now let's look at another example. Let's look at magnesium chloride with the molecular formula of MgCl2. Okay, now when you look at the molecular formula, you see that the total number of atoms of magnesium in this compound is 1. So 1 multiplied by its atomic mass, which is 24. But for chlorine, you can see that we have 2 atoms of chlorine there. Okay, so 2 multiplied by its relative atomic mass. So that will give us 24 plus 35.5 times 2. And that will that will make our MR to be 95. Okay, let's see if you guys can do this one yourself. Now try and see if you can find the relative atomic mass of the relative formula mass of calcium carbonate. Now this is the molecular formula of this compound, CaCO3. So I'm going to give you guys a minute to see if you guys can work out this relative formula mass of this compound. Okay, let's see if you got that right. So let's start. Looking at that again, you can see that calcium is just one atom of calcium in that compound. So 1 multiplied by its atomic mass, which is 40. You go to the next element in that compound, which is carbon, and we have just 1 atom of carbon there. So 1 multiplied by the relative atomic mass of carbon, which is 12. We move to the next one, which is oxygen. So we have 3 atoms of oxygen there. So 3 multiplied by what? The atomic mass of oxygen, which is 16. So we have 40 plus 12 plus 3 times 16. Okay, now that will give us MR to be 100. So how many of you got that? Good job. Okay, nice to have you in this video. I hope you all love this video. So join me in my next class where I show you how to find the relative, the percentage by mass of an element in a compound. Thank you. Bye.